We are going to talk about multiplying binomials. These are going to be special products. But first, let's use FOIL. You should already know how to do this. If I am multiplying a binomial times a binomial, then I will multiply the first, multiply the outer, multiply the inner, and multiply the last. The first term in each parentheses, y times y, is y to the second. The outer terms, woo, on the outside, way out here, y times negative 8. That would be negative 8y. Now let's multiply the inner terms, the ones on the inside, right here on the inside. And that would be a positive 8y. And the last term, many students want to all of a sudden add these. No, you multiply the first, multiply the outer, multiply the inner, and multiply the last term. So the last term in this parentheses is a positive 8 times a negative 8. That would be a negative 64. And then we combine our like terms. I have a negative 8y and a positive 8y. They will cancel. My answer is y squared minus 64. We have a few more problems to do now. I have x plus 5 times x minus 5. Notice we have the same terms, but we have a positive and a negative. I have 3x minus 2 times 3x plus 2, but opposite signs, same terms, opposite signs. 2x plus 7 times 2x minus 7. Now I want you to turn off the video and work FOIL on all of these problems. Go ahead, turn off the video, and I want you to do the FOIL and then turn it back on. Hopefully you got the same answers I did. We had already worked the first one. In the second one, when I multiplied x plus 5 times x minus 5, I got x squared minus 25. 3x minus 2 times 3x plus 2, I got 9x squared minus 4. 2x plus 7 times 2x minus 7, I got 4x squared minus 49. Do you notice anything? These all have a minus sign. They all have two terms, and they're all perfect squares. 64 is a perfect square of 8. Y squared is a perfect square of y. But do any of them have a middle term, like a y to the first or an x to the first? None of them. Because when you were multiplying them, the outer and the inner always canceled. So whenever I have the same terms, in this case, I have 3x and 2, 3x and 2, but I have a minus and a plus. Well, when you multiply the last terms, you know you'll always get a negative. And then when you multiply the outer and the inner, you always get the same term, but one will be a positive, one will be a negative. They'll be opposites, they'll cancel out. These have a special name. Now you may be wondering, well, why do I need to learn a special name? Why can't I just use FOIL because I already know FOIL? Well, you can. But later on, we are going to be doing these problems backwards. We are going to be factoring. So I want to recognize these. I want to recognize these, and guess what they're called? It's not a fancy name. You see the minus sign? That's the difference. There are two things here, and they're both perfect squares. These are called the difference of two squares. They have a minus sign, difference, two things, and they're perfect squares. So you don't necessarily have to know that these are differences of two squares yet, but when you start factoring, you want to be able to look at something very quickly and say, oh, that's a difference of two squares. Later on, when I tell you to factor, and you see something like star squared minus heart squared, this is the difference of two squares. Star squared is perfect of star because star times star is star squared. Heart squared, well, that's perfect of heart. I can quickly factor it. I will draw my two parentheses. I know instantly that this is going to have a positive times a negative, and my answer will be star plus heart times star minus heart. Remember, you need to get really good at multiplying polynomials, so when we have you factor them and you're going backwards, it's all fun and games. Now, we have another special product. Okay, here we go. I have x plus 4 in parentheses squared. In this problem, I could write x plus 4 times x plus 4, and I could use FOIL, because it's a binomial times a binomial. And that will be, you multiply your first terms, what's x times x? Yes, I would get x squared. The outer terms, watch this, the outer term's 4x, and the inner term is also 4x. They don't cancel, they're both positive. So a positive 4x and a positive 4x will be a positive 8x. And the last term in each parentheses, 4 times 4, is 16. Notice, my middle term did not cancel there because I had the same sign. Now what I want you to do is turn off the video temporarily, and I want you to work these out using FOIL, using what you already know. 2x plus 5 in parentheses squared. That means 2x plus 5 times 2x plus 5. Y minus 7 in parentheses squared. That means y minus 7 times y minus 7. 11y minus 1 in parentheses squared means 11y minus 1 times 11y minus 1. I want you to work all of those out using FOIL and then turn the video back on. Okay, so here are the answers. Did you notice anything when you were multiplying these with FOIL? Let's look at something. 9 is equal to 3 squared. 16 is equal to 4 squared. 25 is equal to 5 squared. 100 is equal to 10 squared. All of these numbers are perfect squares. I can think of a number and multiply it times itself and get these numbers. So, when I'm working with trinomials, let's go back to a previous page, and you notice all of these are trinomials. They all have 3 terms. And if I was to factor them, every one of them is a binomial squared. These are called perfect trinomials. Now, once again, I don't have to learn this when I'm multiplying, because I could take x plus 4 squared and know that it is x plus 4 times x plus 4, and I could do FOIL. So why should I learn this? It will make factoring easier for you. So the formula when I do start factoring, how do I know if something's a perfect square trinomial or perfect trinomial? The first term has to be perfect, and a squared is perfect of a. The last term has to be perfect. B squared is perfect of b. And the middle term, you need to be able to multiply these 2 terms, then double it or say times 2. And if that's what you have in the center, then you can quickly factor it. But notice your signs. If my middle term is negative, I will use a minus in my binomial. If my middle term is positive, I will use a positive. Let's try one problem. And let's say I'm telling you to factor this. So this will be in the next chapter. But I'm trying to explain why you want to understand what you're doing when we work with special products. But this is a perfect trinomial. How do I know that? I will look at the first term. This is a perfect number of 12n, because 12n times 12n is 144n squared. The last term is also perfect of 5, because 5 times 5 is 25. We'll multiply 12n times 5. You should get 60n. And then when you double it, or say times 2, yay, we get the middle term. So I do know that this is a perfect trinomial. How do you write your answer? I will take that 12n. I will take that 5. I know it's perfect. So this is something squared. Should I use a plus or a minus here? I want a positive middle term, so I will use a plus. So if I get to where I understand these problems going forward, factoring will be all fun and games.